Hello guys, welcome to calculus class. So this time I will go over 2024 FRQ with a calculator active. Okay, so these questions are really easy, so follow this one. Now in FRQ, if you see table, almost always you're gonna use Riemann sum or slope. So keep that in mind. So let's do this. The temperature of coffee in a cup at the time t minus is modeled by this decreasing decreasing differentiable function c, where c of t is measured in degrees Celsius. So that's a c of t. Check that out from 0 to 12. Select the value of c of t are given the table shown. So approximate c prime of 5. So we want to find c prime, which is since we don't have a equation, we actually have to use the slope formula. So basically, number one, A, we're gonna find where 5 is. 5 should be between 3 and 7. So only thing that we have to do is y2 minus y1 over x2 minus x1, which you will have to write 69 minus 85 over 7 minus 3. So plug this one into the calculator, you will probably get negative 16 over 4, which is gonna be negative 4. Now, unit is important because it says unit, write unit clearly. Now, degrees Celsius per minute. Keep that in mind. So degrees Celsius per minute. If you're not really sure about this unit, just copy this one down per minute, okay? If it was something per minute, then you gotta write per minute per minute. So this is gonna be 2 points already. Let's do B. Using the left Riemann sum with the three subintervals indicated by the data in the table to approximate the value of this. And then you're gonna interpret the meaning of this. So it's a two different thing. This one is the average value. So let's do this one first. Always write this one down first. Antiderivative of 12 to 0, c of t is, I'm gonna use squiggly line because that's approximate, is, now let's do Riemann sum. Here to here is 3, 3 to 7 is 4, 7 to 12 is 5. And because we're using left Riemann sum, we're gonna use left, left, left. So let's do this. 3 times 100 plus 4 times 85 plus 5 times 69. If you put this portion into the calculator, I believe it should be about 985. Now, when you do Riemann sum, this one we don't know the unit because this one is already degrees Celsius, so we cannot even go back. So you can just write like this. That's it. So that's the point. But we also have to write what that means. So if you do 1 over 12, 12 of 0, what that means is, so that's this one means total degree changed over this time. But if you put 1 over 12, which is 12 minus 0, it actually means 1 over 12. Oh, actually I cannot do it. So I'm gonna just write what it means. So this one means that, as I said, it's the average temperature, right? Average value. So I'm gonna just copy this one down. Just saying that average is the average. And because I'm not really good at English, I'm gonna just copy this one down. Average the temperature of a coffee, or no, actually coffee is not countable, of coffee over is the average temperature, not the temperature, average temperature of coffee over t equals 0 to t equals 12. Or you can just write like this, whichever makes you happy. All right. All right, so that's it. Let's go to C. For 12 to 20, the rate of change of the temperature of coffee is modeled by this. So that's the derivative of this. So now finally they gave us the function where C prime of T is measured in degrees Celsius per minute. Find the temperature of the coffee at T equals 20. So you want to know temperature of the coffee at the specific moment, which is 20. So only thing that you really have to do is, because you want to know the temperature of the coffee, you have to take antiderivative of this. And they already gave us the interval. So what I'm going to do is, first antiderivative of 12 to 20, C prime, C prime of T dt, that should be equal to C of 20 minus C of 12. Keep that in mind when you take antiderivative. Antiderivative of derivative is going to be C of T. And now you're going to plug these numbers in. Now this one, I can just plug this one into the calculator because it's gonna, I'm gonna just plug this portion. Let's see if we know something. Now, C of 20, we don't know, but we know C of 12 because it's right here. C of 12 is 55. This is what? 55. This decimals. So let's do this. Now I'm gonna put this one into the decimals. Function, I will go to the antiderivative of, what is it? 12 to 20. Now, let me tell you something. Divide negative 24.55 e to the 0.01 x over x dx. Now they give you answer, but if you don't get it, make sure to put parentheses, okay? Because if you have a more than one term, you will need it. So it's gonna be negative 14.670 or 671. So this is negative, 14.6708 equals C of 20 minus, we already know what, we already know yeah, that's gonna be much better. We already know C of 12 is 55, so I'm gonna write down 55. Yep, so only thing that you have to do is to solve for this. Yeah, solve for this. Again, you don't have to do much. Only thing that I'm gonna do is negative 14.0, not 0, 6708 equals, instead of C of 20, I'm gonna use X minus 55. Here, now I can click it actually, so I'm gonna write C of 20 is equal to, what's it? 40.329. If you cannot click this point, let's say, because that's possible, in the decimals, make sure you change this equal to minus, but don't forget, you gotta put parentheses to the right side. Then, as you can see, you're gonna get the right number, same number, which is 40.329. If you don't put parentheses, as you can see, you are gonna have a whole different number. So when you change equal to minus, just don't forget, you gotta put parentheses, all right? Yes, let's see. Next one. Oh, wait, yeah, that's it. D. For the model, find part C, it can be shown that C double prime is this, which means if you take one more derivative, you're gonna get this, which you can do it by hand, I believe, from here to here. Determine whether the temperature of coffee is changing at decreasing rate or increasing rate. Do you see? It did not say increasing or decreasing. It says changing at decreasing rate, increasing rate. So basically, you're trying to find if this is less than 0, if it's a decreasing state, increasing rate means if C double prime is greater than 0. So let's see which one this is. Again, only thing that we have to do is, even if they did not give us this, we could have just, so keep here. Even if they didn't give us anything, we could have done it, but because they gave it to us, it's not a big deal. F of x equals, actually, you know what? For you guys, let me show you something. Assuming they did not give us this equation here, this is what you could have done. You can put f of x equals, you see this graph? What you could have done is f prime of x. And you can use this like graph here. Like that's very easy, right? But so we can use this exact same graph. But for you, I'm gonna use what they give us, which is 0.2455 e to the 0.01x parenthesis 100 minus x over x squared. So as you can see, do you see these two graphs are exactly the same thing? So that's what I'm saying. You could actually utilize this, but this one they gave it to us, so I'm gonna just use this. So we want to say from 12 to 20. Is that positive or negative? So let's look at it. If you look at it, x equals 12, x equals 20. If you look at this between two, do you see this line is already above 0? Even like in over 20 here, it's already above 0, which means f double prime is already greater than 0. So what you can just say is f double, not f, c double prime of t is greater than 0 on like this. I'm just copying this one down from right here. And again, copy this one down if you're not sure. The temperature of the coffee is changing at an increasing rate. That's it. That easy. So keep that in mind. Usually first two questions of FRQ with a calculator active, they are very easy. Even if you cannot do all 4 questions, I believe you can do at least first 2 or at least these 3. All right. So that's it. Let's go to the question number 2. This one is also easy, so don't give up. Okay. Number 2, it says a particle moves along the x-axis so that its velocity at time t greater or equal to 0 given by v of t. So that's a velocity. Keep that in mind. Is this? There's a time t r. I don't know what this, or they can use a or t of r. They use t of r for no reason because it looks complicated, but it's not. So there's a one point between 0 and 2 where the particle is at rest, which means particle at rest means v of t equals 0. Find t of r. So we're gonna find when this velocity is equal to 0. From that, is particle moving left or right? Left to the right or right to the left? Is that particle is moving to the right or to the left? Okay. If it's moving to the right, that means it's a positive, it's moving to the left. Okay, let's do this. So let's figure it out. So first, I gotta figure out what this point is. So only thing that I have to do is I just have to put this one into decimals. Wait. Oh yeah, I can do it. All right, so let's do this. F of x equals natural log. You cannot put v of f prime of x already. Always you must put f of x no matter what at the beginning, okay? Otherwise, graph is not gonna show. I mean, you can use g of x, but what I mean is you cannot use f prime already, okay? So I'm double checking if I missed anything. I didn't. All right, so this is the graph. So that's the velocity. Now, when are they equal to 0? This one I cannot use because our domain clearly says it should be between 0 and 12. So that is going to be the T of R, which is 1.2425. So here, T of R is equal to 1.426. So let's look at the graph here. If you look at it from 0 to here, do you see this graph is on the positive side? So which means a particle is moving to the right because it's a positive. If it was a negative like this, that's moving to the left. Okay, so I can say that if you don't know English, again, just like me, just copy this one down here, okay? The particle is moving to the right on Z TOP, we already got 1.426 because that's what question is asking, right? Because V of t is greater than 0. Okay, so that's A. Now let's do B. Find the acceleration, which means derivative of this one, of the particle at t 1.5. Show the step for your calculation. Is the speed of the particles increasing or decreasing? Okay, so here's the thing. It says if current is increasing, decreasing, right? If speed, so we want to find if speed is increasing or decreasing. So keep that in mind. Speed is increasing. You don't have to write this one down. This one is just for you. If acceleration and velocity, if speed and acceleration are same sign. For example, if acceleration is positive, if velocity is positive, it is increasing. If it's negative and it is also negative, it's also increasing. Because this one is the speed is increasing from the forward side. This one is speed is increasing from the backward side. Because speed does not have a direction. So speed is absolute value. That's why. Okay. If they have a different sign, let's say positive and negative, which means you're trying to go forward. This one you're going to the backward, which means speed is actually decreasing in that case, and the other way around as well. So keep that in mind. All right. So first we want to find speed here. We already know the velocity, so you're gonna put v of 1.5 is equal to. So let's look at it. This is why you always write this one down, because only thing that you have to do is you gotta find f of 1.5. They gave us number. This is negative 0.0768, and a of 1.5 acceleration, which is same thing as a v prime of 1.5, is here I'm gonna put f prime of 1.5. Okay, I got -1 is -1. So how will you write down the reason? I'll say v of 1.5 and a of 1.5 have the same sign. Therefore, the speed is increasing. Dang, I'll write so ugly. Increasing at time equals 1.5. That's how you do. It's so easy. All right, so that's about it for this one. Let's go to the C. Do you see how easy this is? If you know, so don't panic. The position of the particle, also position. How do I go from velocity to position? Antiderivative, keep that in mind. Position of the particle at time t is equals, okay, so now, you know, in position, I usually use p of t or p of x, but now they use x of t. So x is the y value. So x of t, position at time t is tx of 1 equals -3. So keep that in mind, which means when x is equal to 1, y is equal to -3. Find the position of the particle at t equals 4. All right, so they give us a 1 and 4, right? So it's very easy. Antiderivative of 1 to 4, this velocity v of t dt, it should be equal to, we already know, x of 4 minus x of 1. If you wonder where I got this one from, keep that in mind. It's a like position, right? Antiderivative of velocity is a position. Instead of p, I just used x. Only because they used x, okay? According to this question, they already gave us what x of 1 is, which is -3. So this one is -3. Do we know what this is? No. So this one is a decimals. So let's do this. Oh yeah. So we already got this one. So only thing that we have to do is antiderivative of, I'm pretty sure it was the 1 to 4, right? 1 to 4. Now I don't have to rewrite this entire function again. I will simply write f of x and dx. Do you see they give us a number right away? It's so easy. It's gonna be, so whoa. Here, do you see this one? This whole thing is gonna be, what was the number? 0.1971167 equals x of 4 minus, this is -3 because it's given to us. Again, negative times negative becomes positive. So, yep, and only thing that I have to do is I just plug this one to the decimals and figure out what this is. 0.1971167 equals, instead of x to 4, I'm gonna just use x plus 3. Again, I'm gonna close here. Okay, I can click it because it's more than one term. But again, keep that in mind. If you cannot click it, change it to the minus and put parentheses. Still, you're gonna get the same thing. So I'm gonna put x of 4 is equal to -2.802 or 803, whichever makes you happy. Right? Okay, so that's it. Now let's go over 4. All right, so now we want to find total distance traveled. So keep that in mind. It's a distance. Distance is absolute value of velocity. If it was saying displacement, then only thing that you have to do is absolute value of v of t dt. All right. Now keep that in mind. Distance cannot have negative numbers, so that's why we put absolute value inside. All right. Yeah. So here, do you see this one? Oh, so this is the displacement actually. What we just did right here. That's the displacement. See what happens if we are trying to find distance. So first, we have to write down this absolute value of 1 over 4, absolute value of v of t dt, because that's what question is asking. Because question also says set up for your calculator. So if you just write down the equation, you're wrong, okay? The does it say to write down the unit? No, it didn't even give us the unit, so we're good. So let's do this. Yep, so I mean, only thing that we have to do is we just plug in the absolute value. That's it. Here. 0.958. That's it. Do you see here? I just put absolute value because I already got the displacement, so why do I bother myself to rewrite it? That's it. All right, so that's about it. That's the end of the calculator portion. As you can see, if you know what you're doing, all these ones, they are very easy. All right, so let me know if you have any questions. I'll go over more questions in the next video. I will try to go over maybe 3 and 4 from the non-calculator portion. That's it, guys. I love you. Bye.